In the previous lesson, you learned that variables allow you to store values in your program for later use. In this lesson, we will create two variables to store the two power levels for our automatic straightening behavior and use them to enable quick adjustments to our program. Before making any changes, save your Labyrinth AutoStraight program as Labyrinth AutoStraight with variables. Variables should be created at the beginning of task main, before they're needed in the program. To create a variable, first indicate which type of value you want it to hold. We want to store motor power levels, which are integer numbers, so enter int as the variable type. Remember to do this twice, once for each variable. Now we need to give the variables names. Most names will work, as long as they don't contain spaces or symbols, don't start with numbers, and aren't already reserved words in Robot C. It's good programming practice to choose variable names that describe the values that are being stored. Name the first variable normal speed. We'll use this variable to store the normal speed of the motor. Name the second variable slow speed. This will be used to store the slower speed. With both the types and names of our variables defined, they have been created. Before we can use them, though, we must give them their initial values to store, or initialize them. On separate lines, set the variable normal speed equal to 63 and slow speed equal to 50. Note that there are shortcuts to creating and initializing variables in Robot C, but this method of creating and then initializing will always work. Now, in our first automatic straightening behavior, replace each instance of the 63 power level with the variable normal speed. And the 50 power level with slow speed. Let's download our program and try it out before making further changes. Pause this video now to test your own code too. The robot performs just like it did before. When the robot reaches one of our variables in the program, it checks what value is stored in the variable and uses it as the motor power. Now modify the remaining instances of the automatic straightening behaviors to also use these variables. You can copy and then paste the first set of if statements to save time. Before we test our changes, let's also speed up the forward movements of the robot. Set the normal speed variable equal to 80 and slow speed equal to 65. Download and run. The robot completes the labyrinth faster and just as reliably. With the variables in place, you should now tweak the two power levels specifically for your robot. Remember, if your motors are very similar, you can decrease the gap between the two values for a more efficient and less wobbly robot. But if your motors are very different, you may need to actually increase the gap for the robot to effectively self-correct its movements. Even if it takes several attempts before you find the best combination of motor powers for your robot, making those tweaks is quick and painless.